The prevention of a pandemic is a really complex process that really requires a multidisciplinary set of skills. And so people often think about doctors and nurses, but it's really so much more than that. It's public health officials, it's utility operators, it's basic scientists, it's engineers, it's policy people. It's really an entire community. My name is Scott Berry, and I'm an associate professor in mechanical and aerospace engineering here at the University of Kentucky. As an engineer, where I fit in is, this is unprecedented territory. When we look at the methods, as engineers, we can see the inefficiencies, we can see the flaws. Overall, what we do is we develop medical diagnostics, so test for certain diseases, with really an emphasis toward developing things that can be used in low resource settings where traditional technology isn't available. More recently, we've been expanding into environmental surveillance, where we test environmental samples like wastewater to detect human pathogens as a way to estimate the prevalence of human pathogen levels within a community. This is a collaboration that began really early on in the pandemic, together with another scientist named Dr. James Keck. And what we started to do was develop our own environmental assay for wastewater. And the first thing that we tested was later that fall when the students came back to campus. Here at UK, we tested the wastewater from the dorms. From there, we tested 6 nursing homes around Kentucky, looking at SARS-CoV-2 levels in the wastewater, and we would inform the nursing staff when we saw a spike so that they can enact increased safety protocols. From there, we went into Appalachia, one of the most underserved regions of the United States, and we really wanted to bring cutting-edge technology out there. And so we actually had a group of students, as part of an engineering capstone project, design a lab in a van where we can drive around, we can collect samples, we can do the analysis right there in the back of the van and have answers for that community about the levels of disease within just a few hours. So that's really great for public health response to have information that rapidly. Because what we've also seen is that the signal in wastewater goes up just a few days before we see a huge rise in clinical cases. I really think wastewater surveillance is a powerful tool for monitoring emerging diseases. And if we had systems like this in place at the beginning of SARS-CoV-2, I think we could have stopped it in its tracks. We were fortunate to get a center award from the National Science Foundation to found a center to look at pandemic prevention. And so we've started the Environmental Surveillance Center for Assessing Pathogen Emergence, or ESCAPE, here at UK. This involves a partnership between UK, Arizona State University, the University of Alaska, the Alaska Native Tribal Health Consortium, and the Wildlife Conservation Society. So many different groups across a huge geographical distance, as well as a diversity of different skills. And so what we're doing here in the lab is developing new technologies that are simple to use, that can bring this type of analysis really to anywhere in the world. So our overarching goal right now is to enable environmental surveillance to be done by anyone, anywhere. The take-home message is that pandemics know no boundaries. And so if environmental surveillance is going to work, it really needs to be global. You can't just focus on your community and hope for the best. And so hopefully there's support out there for doing surveillance in other countries, in other places, beyond the places where people live that are watching this right now. And hopefully they can appreciate how this benefits them as well as the rest of the world.